The atmosphere is composed of mixture of many gases, water vapor and other solid particles. The major components are nitrogen 70%, oxygen 21% and other gases 1%. Argon, carbon dioxide, neon and other gases can be found in the atmosphere. The atmosphere is divided into 5 distinct layers based on the temperature variations. They are troposphere, stratosphere, mesosphere, thermosphere, exosphere. Troposphere is the lowermost layer of the atmosphere. It extends approximately to a height of 8 km from the poles and 18 km from the equator. The height of the atmosphere changes seasonally also. It increases during summer and decreases during winter. All weather phenomena occur in this layer as it has dust particles and water vapor. This layer has clouds which are produce precipitation on the earth. The sun's rays directly fall on the earth and they are deflected back into the atmosphere. The atmosphere temperature decreases in the atmosphere with increase in latitude at the rate of 1 degree Celsius for 165 meter or 6.5 degree Celsius for 1000 meters of ascent. This is known as the Laplace rate of temperature. This is the densest layer as it contains 70 to 80% of gases. The outer boundary of the atmosphere, troposphere, is called tropopause. Stratosphere is the second layer of the atmosphere found above the troposphere. It approximately extends to a height of 50 km above the Earth's surface. Temperature is constant up to a height of 20 km and increases gradually up to the stratopause, where temperature is nearly minus 4 degrees Celsius. The lower part of this layer is highly concentrated with ozone gas, which is called as ozonosphere. It prevents the ultraviolet rays from the sun to enter into the lower part of the atmosphere. As the rays are highly harmful, it causes skin cancer and other ill effects to living organisms. But the ozone layer safeguards the life on the earth. Mesosphere is the third layer of the atmosphere, found approximately up to a height of 80 km above the surface of the Earth. It is the coldest layer of the atmosphere. The temperature decreases with increase of altitude due to the absence of ozone. Its upper boundary is called mesopause, where temperature reaches the minus 90 degrees Celsius. Luminous noctilucent clouds from here due to the presence of cosmic dust. Meteors falling from the space get burned in this layer. It is because where meteors hit the air gets compressed and heated up, causing the meteors to burn out. Thermosphere. The ionosphere is the fourth layer of the atmosphere, extending approximately up to a height of 400 km. The temperature increases rapidly up to 1000 degrees Celsius. It is due to the absorption of very short wave and high energy solar radiation by the atoms of hydrogen and oxygen gases. When light energy is transformed into heat energy, some gas molecules lose or gain electrons and become the charged particles called ions. The charged particles forming the lower part of the thermosphere as a zone is called as the charged particles forming the lower part of the thermosphere as a zone is called as the ionosphere. These ionized particles create auroras at higher latitudes. Ionosphere can reflect radio waves back to the Earth. This facilitates long-distance wireless satellite communication. The credit of discovering ionosphere goes to Henley and Heaviside. The upper layer exosphere is the uppermost layer of the atmosphere, which extends into the outer space from above 400 km up to 1600 km. It has rarefied contents. It contains mainly oxygen and hydrogen atoms. These atoms can travel hundreds of kilometers without colliding with one another. Thus, the exosphere has a exosphere has no longer behaves like a gas. The temperature increases with the increase of altitude and it ranges as high as 165 degrees Celsius. The gravitational pull is minimum in this layer. This layer gradually merges with the space. Ozone O3 is form of oxygen that combines three atoms into each molecule. It absorbs and filters the harmful and ultraviolet B radiation coming from the sun. This way, the ozone layer protects all the life on the earth. However, Ozone is harmful when it develops near the ground. It causes health problems like asthma and other respiratory illness. A steady decline in the concentration of ozone in the Earth's stratosphere is called ozone depletion. Ozone depletion occurs when chlorofluorocarbon and halon gases formerly found in aerosol spray cans and refrigerants are released into the atmosphere, and they cause chemical reactions that break down ozone molecules and reduce the concentration of them. Nitrogen oxide released by emitted by supersonic aircrafts can also destroy the ozone molecules to break down. Ozone depletion substances are present throughout the stratospheric ozone layer because they are transported great distances by atmospheric air motions. The severe depletion of the Antarctic ozone layer is known as the ozone hole because of special atmospheric and chemical conditions that exist there are nowhere else on the globe. The very low winter temperatures on the Antarctic stratosphere cause polar stratospheric clouds to form. Special reactions that occur on uh, polar stratospheric clouds combined with the relative isolation of polar stratospheric air allow chlorine and bromine reactions to produce ozone hole in the Antarctic springtime. Satellite images of the Earth over last decades observe that the atmospheric ozone layer is getting thinner. On October 2, 2015, the ozone hole was recorded to its maximum size of 28.2 million square kilometer over Antarctica. The rise of ozone layer is size of ozone layer is larger than the size of the continent of North America. The ozone holes over the Antarctica allow the ultraviolet radiation to enter and cause of global warming, skin cancer, eye cataract, and even blindness. Depletion of the ozone layer has consequences on human, animal, plants, and microorganisms. This typically results from higher UV levels reaching us on the Earth. Research confirms that high levels of UV rays can cause non-melanoma skin cancer. To protect the ozone layer for our future education, a generation avoid using products which are emitting pollutants such as aerosol sprays, blowing agents for foams, and packing materials as solvents and refrigerants.